Now, we have a very important topic to be discussed, that is principle of conservation of linear momentum. A very important conservation laws. There are some important conservation laws, but out of those, I hope and I think this is one of the very important conservation laws, that is principle of conservation of linear momentum, that is the conservation of linear momentum. You can write down the statement first. Please write down the statement first. It states that in absence of any external force, in absence of any external force, the total linear momentum of the system remains conserved. The total linear momentum of the system remains conserved. That means if no external force acts, there may be the internal forces. Internal force means in between the bodies, the force which is acting. First of all, I just tell you what is a system. A system may consist of a number of bodies. In our discussion, I am taking the case of only two bodies, but it can be generalized to a number of bodies. Let us consider two bodies A and B moving along the same direction with the linear momenta. Momenta is the plural for momentum. So let us consider PA vector and PB vector are initial linear momenta of A and B respectively. Two bodies A and B respectively, their linear momenta are PA vector and PB vector. Now, PA dash vector and PB dash vector are final linear momenta of the bodies. But before that, I just tell you, these two bodies are moving along the same direction, suppose the speed of A, velocity of A is greater than that of B, then what happens? Collision takes place. A goes and collides. A is colliding with B. After collision, obviously it's a mutual interaction. After collision, what will happen? Action and reaction. Forces will be acting on both. Okay? Suppose A is giving an action, B will give the reaction according to Newton's third law. Right? And what will happen? After that, their momenta change. Their momenta become PA vector dash, PB vector dash. These are the final linear momenta. I hope you have understood the case, the condition. Now what will happen? When they collide, according to Newton's third law, when they collide according to Newton's third law, what will happen? If AB vector is equal to minus F BA vector. I remind you, dear students, I have told you in the last class, it is if AB means force on A by B, and if BA vector is force on B by B. Mutual force, internal forces. These two forces are not the external forces. These two are the internal forces. Right? Internal forces which are acting on the body. Then what will happen in that case? Now try to follow me. Here the force is acting on A Be clear? Here the force is acting on B. We have to be very clear. Now, by second law, obviously Newton's second law, what we can say? We can say by Newton's second law, rate of change of momentum is equal to the force. Rate of change of momentum. Can I write? F vector is equal to delta P vector by delta T. Change in momentum. I am not writing it in the differential form, delta form. Delta P vector means change in momentum. Delta T is the small time, which indicates delta P vector should be F vector into delta T. I just keep in our mind this thing. Now, let us come to this expression. Can I rewrite this expression like this? F vector AB into delta T is equal to minus F BA vector into delta T. What is delta T? Here, delta T is time of contact. Look, what happens? What is time of contact? When the two bodies collide, for a very small time, they will be in contact with each other. Although it's a very small time, but when two bodies collide, on collision, they will be in contact with each other, although for a very small time, but they will be in contact with each other. That is called time of collision. So, delta T. So, what will happen? According to this expression, here I have highlighted this expression. From there, F vector into delta T is equal to change in the momentum of the body. Let us come here. F AB vector into delta T. Force किस पर लग रहा है? A body पर लग रहा है. Force is acting on body A. That's why momentum change will be there in the body A. Body A में momentum का change होगा. मतलब क्या होगा? Delta PA vector is equal to minus delta PB vector. Delta PA vector is equal to minus delta PB vector. Look, delta PA vector is equal to minus delta PB vector. Very simple, isn't it? So, this is happening. चेंज इन मोमेंटम किस में हो रहा है? यहाँ A में हो रहा है, यहाँ B में हो रहा है. क्यों? क्योंकि फोर्स जिस बॉडी पर लगेगा उसी का मोमेंटम चेंज होगा. ना मोमेंटम चेंज इन द बॉडी A क्या होगा? ऑब्वियसली फाइनल माइनस इनिशियल मीन्स व्हाट वी कैन राइट हियर. हियर आई विल राइट PA डैश वेक्टर माइनस PA वेक्टर. फाइनल मोमेंटम माइनस इनिशियल मोमेंटम ऑफ द बॉडी A is equal to, with negative sign, PB dash vector minus PB vector. I can write it like this. No problem. Then, in the next step, I just remove it here. I am writing it here. Look, I am writing here. PA dash vector minus PA vector is equal to minus PB dash vector plus PB vector. Look, I write it like this. Then rearrange it. How much you are getting? You are getting PA vector plus PB vector is equal to PA dash vector plus PB dash vector. Just see this. What you are getting? Vector sum. I say vector sum of the initial momentum is equal to the vector sum of the final momentum of the system. मैथमेटिकली हम इसको क्या कहेंगे? वेक्टर सम. चूंकि ये वेक्टर उसका डायरेक्शन को लेकर किया जाएगा, तो वेक्टर सम ऑफ initial momentum of the system is equal to the vector sum of the final momentum of the system. You can write. So, this is the proof for the conservation principle of linear momentum. momentum. This is the proof for the conservation principle of linear momentum. Mind this. Conservation principle of linear momentum is a vectorial statement. Very important to note that it is a vectorial statement. Right? That means we have to consider the direction. That's very important. We have to consider the direction. Like how we have to consider the direction, I am just explaining. Let us see. I am giving you just with the same thing, I am giving you an example. Very important example is the recoil of a gun. A gun recoils. When a gun is fired, it recoils. How it will be? Suppose this is the barrel of the gun. Here it is. And the bullet is fired from here. Okay. I consider, look what I do here. Try to follow. Suppose capital M and small m are masses of gun and bullet respectively, and capital V and small v are velocities of gun and bullet respectively. Alright? Actually what happens? It's a very common experience. When a bullet is fired from a gun, the gun recoils. Recoil का मतलब reaction force. पीछे shoulder पर एक reaction force लगता है, या when you are firing, it always gives a reaction force. The reaction force, that is called the recoil of the gun. Isn't it? Recoil of the gun. So we can apply in this how it will be applied. I am coming to the next lecture. This is the description. I am coming to the next lecture. I will be explaining it in the next lecture.